Hi, my name is JC. I am an application engineer in Maxim Integrated. Today, I'm going to show you the MaxRefDes 179 reference design. The MaxRefDes 179 reference design demonstrates a system with a standalone 45W USB Type-C PD, fast charger, fuel gauge, and protection solution for 2S lithium-ion batteries. At the same time, it is also capable of providing 8 amps output at 1S voltage efficiently to power the system. Now we are going to discuss about how to set up the reference design. First, connect the USB cable from your PC to the MaxRefDes 179 reference design. You may observe LEDs light up. If this is the first time you are using the reference design, please allow a few seconds for the Windows OS to install the driver properly. Next, we're going to connect the battery simulator to the BAT-P and BAT-N pin. Preset the battery simulator to 7.4 volt with current limit at 100 mA. Toggle the switch 2 while turning on the battery simulator to wake up the MAX 17320 fuel gauge. Toggling switch 2 is only needed when previously battery is disconnected from the system. Ensure the battery sourcing current is below 2 mA. Then only increase the battery simulator current limit to 5 amp. Now let's start the MAX 77932 Ref GUI. Click at the Device Connect button. A pop-up message indicates the successful connection to the MaxRefDes 179 reference design. Please proceed with read and close. Let's click at USB-C port to understand the status. As this is initialization, we should observe no connection at the USB-C port. V-bars should stay low. Let's move on to look into charger details. MAX 77960 charger shows that it is supporting 2 cells configuration. QBAT status is correct as battery is supplying power to the system. The smart power selector is configured to turn off the charger, OTG, and no DC-DC. Next, let's connect with a fuel gauge MAX 17320 Ref GUI. At the bottom right, the indicator shows that the GUI is able to read the fuel gauge status. Right after initialization, you can observe channel 3 is the battery voltage that supplied to system is about 7.4 volt. So this is aligned to what we have set on the battery simulator. Channel 2 is a I2C clock. It is pulled up to 1.8 volts. Channel 4 is V-bus. It is 0 volt because there's no power adapter or device is connected. Channel 1 is a CC pin. It indicates that it is operating in DRP mode. This is a correct behavior of the initialization. When the power adapter is connected, the reference design is capable of auto-negotiate for the highest PD profile, 45W. We are using 65W power adapter for this demo. Let's plug in the power adapter. From the waveform, we can see the CC pin is transitioned from DRP to sync mode. PD controller MAX 77958 has automatically negotiated for 45W. We can see V-bus is negotiated from 5V to 15V. Let's read at the USB-C status. The V-bus ADC also shows that it's at about 15V and the CC pin operates in sync mode. Let's confirm the PD profile. Let's read what PD profile that is negotiated. So it shows that the power adapter actually has 5 PDOs, or from 15W all the way to 65W. So what our reference design did is automatically negotiated for the highest PD profile, which is 45W for the better efficiency. Let's read that smart power selector. So it's confirmed that the charger is working, the DC-DC is on, while we are turning off OTG mode. We can confirm that the fast charge current is at 3 amp. The charger detail shows that it is a constant current mode. Let's look at the fuel gauge GUI to see the real-time graph. The charging current has raised up from 0 to 3 amp. Battery voltage has increased from 3.7 to 4 volt. The next demo that we would like to show is how to manual negotiate to user preferred PD profile. Now we would like to manual negotiate for 15 watts. It is at PDO1, so what we can do is select source cap request, key in 1, you can click right button. From the waveform, you can see VBus is negotiated down from 15 volt to 5 volts. So we can confirm again by reading the USB-C status. So VBus ADC shows that VBus is about 5 volt. You can go to command and read the current source cap again. So as you can see, the first PDO is selected, which is 5 volt 3 amp. Now we would like to demo OTG mode. First, we confirm VBus is 0 volt and nothing is connected on the USB-C port. You can read the USB-C status to confirm there's no connection. In this demo, we are going to use a power bank with a micro B input. So I have a USB-C to micro B cable, so we can connect to our reference design. Let's look at the waveform. As you can see, once we plug in the power bank, VBus ramp up to 5 volt to start charging the power bank. So we can confirm again by reading the USB-C status. So right now, our reference design actually operates as a source. We can see it is supplying 5 volt to the VBus. From the Smart Power Selector register, we can see OTG mode is on. Fast charge battery has been a critical feature in the handheld devices. PPS feature is able to maximize power adaptive efficiency, minimizing the charging losses and improve the charging time. It involves optimizing VBus voltage and current level during charging. In this demo, we are using Samsung TA 25 watts with PPS feature. Let's insert Samsung TA to the reference design. We have developed a script to enable PPS function. It will request for a new APDO to increase 500 mV per second from VBus 5 volt to 11 volts. Let's use the GUI to enable the script by clicking on the Tools, Run Script, load the script, then let's execute. Assuming the system would like to optimize the charging by adjusting the VBus level by increasing 500 mV per second to charge the battery efficiently. So here we can observe VBus increase 500 mV per second from 5 volt to 11 volt that described previously. If you're interested to manually enable the PPS feature, you can go to Command tab of the USB-C and then select Set PPS Mode. Let's enable the PPS feature, and by starting with a VBus 5 volt 1.5 amp, and then we plug in Samsung 25 watt TA with PPS feature. You may observe VBus at 5 volt 1.5 amp. Then we would like to manually increase the VBus by requesting for a new APDO. Let's set request APDO position to number 4 because the Samsung 25 watt TA is able to support from 3 volt to 11 volt at 2.25 amp maximum, and we would like to increase to example 5.5 volt at 1.5 amp. Let's click right to request for a new APDO. Let's look at the VBus waveform. We can see the VBus increased from 5 volt to 5.5 volt. This proven that our reference design is able to support PPS feature. In this demo, we would like to showcase 2S to 1S conversion with MAX 77932 switch capacitor converter. First, let's power up the MAX 77932 with I2C command. Click at configuration in the GUI and then enable switch capacitor by pressing the right button. Let's look at the waveform. Channel 1 is the I2C clock, and then channel 2 is the input voltage. Channel 4 is the output voltage of MAX 77932. Channel 3 is the power good signal. As we can see, input voltage is about 7.4 volt and output voltage is 3.7 volt. This showcases that there's a 2S to 1S conversion. Next, we would like to showcase how to power down the switch capacitor with I2C command. Let's go to the GUI configuration. Click on the button to disable the switch capacitor. Click right button. Based on the waveform, we can see channel 4 output voltage is powering down once it receives the disabled signal. Next, we would like to demonstrate loading the current 8 amp at the MAX 77932's output voltage. By default, the overcurrent threshold is 8.8 amp. Now I'm using electronic load to apply 8 amp the output voltage. As you can see, the output voltage is still maintained half of the input voltage. And that's it for the demo. Thank you for joining.